How's everyone working today on multiplying binomials together, and they create a trinomial when you multiply them. And really, like I said, we want to make sure this skill is something that you have, because when you factor, it's moving backwards. Okay, so we're talking a little bit about the relationship between multiplication and division. I just really want to share that with you one more time. So if you have 6 times 7, that gives you 42. Okay, but there's a relationship between these three numbers with division that keeps them all kind of connected. So 42 divided by 7 is 6, and 42 divided by 6 is 7. So being able to see that with the polynomials when you're multiplying them together, and then when you're breaking them apart, it's almost like you're dividing in so many different ways, and that becomes more clear the more you do these. So I'm going to do number 13 with the setup. I'm going to do number 14, just kind of multiplying them together, and then of course I'm going to let you do 15 and 16 on your own. Okay, so actually I think I'm going to flip that. I'm going to do 15 and 16, and I'm going to let you do the top ones. Okay, honestly I just want to see how you do with the negatives on 15. So there we go. So if I was showing you today the distribution concept, I need to take this 7n and multiply it to the 7n plus 6. Kind of like, well, just like distribution. Okay? And of course, when I do that, 7 times 7, 49n squared. Watch your squared. That's where I see a lot of mistakes. 7n times 6, 42n. Okay? So I've distributed 7n through that second parentheses. You're never going to multiply these in the front. They're adding. 7n plus 5. They're never going to multiply. Just like 7n and 6. They're never going to multiply because they're technically adding in here. So now I'm going to do that same thing. I'm going to distribute 5 to this parentheses. Okay? Now, like I said, once you've done this a lot, like I have and other students have, you don't necessarily have to set it up all the time. But at first, it's good to really kind of see how that's working. That's 35n, and that's 30. Okay? So I'm going to scroll down just a little bit so I can get a little bit more room. And like a lot of times, you really need to look for this right here. This is 49n squared. But in the middle, 42 plus 35, 4 plus 3 is 7, and 2 plus 5 is 7. So those are combining to really give you 77n. Okay? So that is a pretty tough factor. If I gave you 49n squared plus 77n plus 30, and I asked you to factor that, man, that'd probably be a little tough. But really, if you think about it, what multiplies to be 49? 7 and 7, right? And what multiplies to be 30? 5 and 6. Now you may have to play with that. If you didn't know where to put it, you got to really put it in there and see which way is going to multiply correctly. But if you really start paying attention to the numbers here and how they are formed through multiplication at the beginning, the factoring starts to make a lot more sense. Okay, so I'm going to jump in here. I'm going to multiply these together, but I'm not going to set up that first line. Okay, because honestly, I want you to be able to do it correctly, but if we can be any faster than you were the first time you did it, that's obviously better. So I'm going to multiply 4n times n. 4 times 1 is 4, but there's 2 n's when I multiply, so I need n squared. Okay, 4n times 4, 16n. So I've distributed the 4n to the second parentheses, and now I'm just going to slide over and multiply the 5. 5 times 1n, 5 times 1 is 5, 5n is the result, 5 times 4, 20. So basically, we have some like terms just like we had last time. If you do this enough, you should predict that to be true every time. So we have 4n squared, 16 plus 5, this right here is giving me 21n. And then, of course, the back is not changing, and that gives me 20. So again, just to really kind of think back why those numbers are the way they are, 4n times n, 4n squared, 5 and 4 make 20, okay? But really, like I was saying, that 21 comes from the middle, that 4 times 4, 16, 5 times n, and that's where you're getting 21, okay? So honestly, the reason why I signed as many as I did is because I really just want that to be something you've done enough that you've started to create an understanding of like how that works, and it becomes way more natural. Okay. So I gave you a few problems of review. This is the greatest common factor idea. So I'm going to work this left side, okay? And I want you to really focus on the right side. So those are the ones I'm going to really come in and look for. Obviously, if you watch the video, you shouldn't have problems with the first two. It's more the second two that we're checking. So when I look at this first one, 2 and 5 kind of throws a lot of students off at first because they don't really have anything in common. I'm supposed to factor something out, but they don't have 2 or 5 in common. So the thing is that they don't have a number in common like that, but they do have a variable, x to the 4th and x. They both have x in common. So what I can do, and this is really all I can do to the problem, is I could take an x and put it out front so that if I distribute it to the same thing that's in there, like 2x to the 3rd, that way it would bump up in power and then be the original 2x to the 4th that you're starting with. Well, same thing here, x times 5 is how I'm going to get 5x. So all I'm doing is taking 1x off of each of these. So instead of 4, I have 3, and instead of 1, I have none. Okay? So this one, they don't have a variable in common. This last one doesn't have an n. So we aren't taking a variable, but we will take out some number that 21 and 70 have in common. So let's do a longer one, 32a, 48a to the 3rd, and then 8. So I noticed that the last one does not have a variable. So I'm not, like on 17, I can't pull a variable off if they don't all have it in common. But 32, 48, and 8 all have 8 in common. So I'm going to take that 8, and I'm basically going to divide 8 into each of these numbers. But I don't want to lose that 8. I want to make it where 8 would multiply into the parentheses with distribution to give me my original polynomial. So 32 divided by 8 is 4, but I still need the a so that when I multiply, you get what you started with. Okay? Negative divided by a positive is negative, and 48 divided by 8 is 6. And then, of course, I still need that a to the 3rd. Now, this can be tricky unless you haven't done a lot of problems. If you've done a lot of problems, this becomes a lot easier. But when you take an entire term out, like 8 divided by 8, I need a 1 there. And that's true even if there's a variable. Okay, if there's a variable and they're the exact same thing, just put a 1 in its place so that when they multiply, it gives you exactly what you started with. Okay. All right. So let's take a look at the next section. The next section is what we really spent a majority of the class thinking about, and that was this concept of factoring. How do you rewrite it in a way where it would multiply to be with what you started? So I'm going to do a few of these, and of course I want you to take off on the ones I don't do. So again, we're setting this up. They don't have a greatest common factor like these last ones. Okay, it's kind of a special type of factoring. But they do have this special relationship where two binomials would multiply together to be with what you started. So n times n is where we're going to get n squared. With 20, we have 1 times 20, 2 times 10, or 4 and 5. Okay? So if you were paying close attention today, or if you got home and you're like trying to remember how this works, we're trying to multiply to be that back number. If you remember, whenever this last step happens, 5 times 4 gives you 20, that back number. We're thinking about that here. So which of these would multiply to be 20 while still getting you to 12, specifically negative 12? So 5 and 4 could add or subtract to be 9 or 1. 1 and 20 could add or subtract to be like 19 or 21. But 2 and 10 could add to be 12, could subtract to be 8, or even negatives of these values as well. So if I'm wanting to get to a positive 20, that means both of these signs are the same. They're either both positive or they're both negative. Well, if everything's positive, then I won't get a negative 12, and so that negative 2 and that negative 10 is how they're going to multiply to be 20, but still add to be negative 12. Okay? So this next part's not necessary, but really important. If you know you did it correctly, then you feel confident as you go. N times n squared. N times negative 10, negative 10n. negative 2 times n, negative 2n, and then negative times a negative, positive 20. So this right here is where you're getting that negative 12 from in the middle. So this is definitely correct. Okay, that's how you check it. Just like I said with multiplication and division, they're opposites. If I want to know I did this correctly, I just multiply them together. Okay, so let's think about a few more. Multiplies to be negative 12. So I'm just thinking about 12 for a second. 1 times 12, 2 times 6, 3 times 4. So which of those numbers could add or subtract to be this negative 1 that we see as a coefficient in the middle? So again, I'm looking for numbers that could subtract to be negative 1, and I'm locking in on 3 and 4. Okay, 3 minus 4 is negative 1. So when I go to build those parentheses, I'm going to have two n's. That's how they're multiplying to be that n squared in the front. But to get to negative 1, I need a positive 3 and then subtract 4. And so that's the signs within that polynomial. Okay? And I think that's where I'm going to stop. I want you to try these last 4. Obviously, I hope that helped you get going. I want you to try these last 2 in the middle, and then, of course, those first 2, 13 and 14. Hopefully that is just enough to get you going. I hope you had a good day at school, and I hope this really helps you. Email me or please ask questions tomorrow. I'll go over it, and I'll check the work. Have a good night.